Alright, I think I'm live. Hello again, everyone. Um, it's been a little while. Just just a little while. Um, I'm back. I'm basically going to be doing exactly the same thing I was before, except I think this time I'm going to, just restart it because I have a couple of ideas that I would like to try out. Hmm. 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 I. Okay, it is working. Okay, it said it was. It is working. Okay, it said it was. It is working. It's weird audio. It said it was. It is working. It's weird audio. It said it was. It is working. It's weird audio. It said it was. It is working. It's weird audio. It said it was. It is working. It's weird audio. It said it was. It is working. It's weird audio. It said it was. It is working. It's weird audio. It's okay, I'm gonna try that one more time. Okay, it sounds good now. So basically, what I was saying is that I'm I've decided to restart from scratch because there's a couple different things that I'd like to try out. I think I didn't really go through it very well last time, so I'm just gonna start again. Don't worry, all the code is still there if I ever want to fall back on it or you guys don't like it. But yeah, hello, I'm back. It's been a little while. But, yeah. I think I'm gonna go ahead and get right started on this. So, there's a few theories I'd like to try and test out, and I think I'm also going to go ahead and make it 64-bit this time. So let's just start with the basics. And then, okay, cool. Everything works. Let's go ahead and make our directories. So source, and then build, and then I guess I can also do bin right as well. So let's go ahead and bring main.c into source and bin into there. I don't know if I'm going to need like linking though. I don't even know if restarting such a project is normal. More bits for the bang. Yeah, exactly. That's what I was thinking. And more bits is also better for what I'm thinking of trying to do. I don't know if it'll work very well in software though. Okay. Right. I was just gonna do that. And then make a lib folder, and then a make file. Alright. So I guess I can just do compile for now. So gcc main.c dash o. Oh wait, I have to do the source slash main.c dash o build slash main, and then run is just gonna be build slash main. There we go. Not too much to it. So, to start it off, I guess I should probably go ahead and do my types.h. Oh wait. Ooh, it's been a little while since I did some programming last. So, 64, and type def long, int 64, okay. And then we can just separate them like that. And start off here. So type def unsigned char uint8 type def unsigned short uint16 and then int there we go. And type def char int 8 int 16 int 32. Okay, and that's probably good to start off, although I should probably do a little bit of Boolean, so define bool unsigned char, define true 1, and define false 0. There we go. That should be fine. I probably don't need to deal with floats or anything like that right now, so I think I'll just stick with this and add more as things go. So, I guess like before, I'll just start with the registers. I'm probably going to have 16 registers, because I want to go a little bit more on the RISC side of things. And I know a little teeny tiny bit about RISC. I don't know if I know enough for it. I'm sure I can find it out if I look it up, though. So, how should I structure the registers? I guess an array would be the best way to do it. So, uint64 registers. Oh, wait. Registers 16. Correct? Oh, right. Duh, I need to include it. Include lib/types.h. There we go. There we go. And then yeah, I guess the general purpose registers can be the array, and then the pointer registers and, you know, other special registers don't have to be. So uint64 p1 and uint64 p2. I can just set them to 0 probably. Oh, don't want to forget that semicolon. And then uint64 instruction register equals 0. And uint64 data register. There's gonna be some with 2 arguments, aren't there? I don't know how I'm gonna go through that. That's super duper difficult. I had a separate second operand instruction, but I don't know if that's really all that good. Because, you know, it's like a whole extra instruction that I have to use. But I can't think of any other way to specifically do it. So I guess I'll just have dr1 and uint64 dr2 equals 0. There we go. That's probably good in terms of registers. And then uint8 memory equals uint8 malloc. There we go. That's 1 gigabyte. Not allowed in a constant. Oh. I guess I could put it in here. There we go. Yeah, okay, so 16 general purpose registers addressed like that because they'll have hex codes and it'll just be easier to address them like that. Okay. So then next, I guess I can go with well, I guess first I should probably run this and make sure it works. Oh, whoops. Uh-oh. Okay, yep, it works. So, allocating 1 billion bytes works. Malloc probably isn't the best function to use. No, there's nothing else to it. It just probably isn't the best function to use. It'll be fine, I'm sure. Okay. So let's start with just a first instruction probably. That's probably going to be a good idea. So LDA 0x. I'm going to need to write 64 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 16. 32. 64. Perfect! Oh, wait, that's hexadecimal. I don't need 64 digits. I need a quarter of that, so 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There we go. I guess that works. And then a copy instruction, and that's just gonna be 1, 0. Okay, that's probably good. So mainly things are going to be done on registers, but data probably should be able to be moved in and out of memory using pointer registers. So I think that's what I'm going to go ahead and do. So I'm probably going to need to make a alias, no, I'll just do instructions.h. There we go. Okay, so define R1. Ooh, thunder. Looks like it's starting to rain. I'm gonna close my window. Oh wait, 0x. I'm probably going to need to start with 0 because of how it's going. Looks like I skipped one there somehow. Oh, whoops, not Control B, Control V. Perfect. That's... Wow, I didn't even think of that, but that's perfect. Goes straight from 0 to F. And then... There. That should probably do it. Yeah. For P1 and P2, I'm probably going to have specific LDP instructions where, I wonder if P should, for example, only be loaded into by a register, but that adds some more overhead. Reduces the amount of instructions I need, though. Okay. So void process instruction, and then uint64 instruction uint64 operand, just for now. And this will process instructions and operands given. And for now, oh wait, not LDA, LDI. I don't know what LDA means. Oh, I need 2 operands. Yeah, because there's got to be some way to have it add operands, because I doubt RISC CPUs do it. I could not fathom how a CPU could hold two instructions, or 2 operands with 1 instruction, without making it larger. And typically instructions are all the same size in RISC. I don't know, like, do I just have 3 quad words? I mean, that takes up a lot of memory. I don't know. So operand 1 will be the register. So registers operand 1 equals operand 2. Okay. I'm probably going to need to it is less than or equal to R16, and I'm going to need to include that header file. So include lib/instructions.h, and I can probably move these in there too. So let's go ahead and do that. I can just do that. There we go. Else if operand oh wait, no, there is no else if. Oh wait, else I'll keep this empty for now, but error stuff later. I'll fix how the CPU handles errors later. I found it easier to design the desired instruction set first and then design the CPU to handle them. Oh, you know what? That's probably a good idea. I don't know why I didn't think of that. Okay, so let's define the rest of the instructions then. That's probably a good idea. So let's see. LDR for loading data into a LDP, sorry, not LDR. LDP to load something from a register into register P. So let me load from a register into register P. There we go. And then this will just be 3, or wait. These need to be bytes. Okay. 1, 2, 3, 4, 5, 6, 7, 8, or not bytes, but bits rather. 8, 16, 32. Come on. 64. There we go. And then copy this and paste it right there. 1, 0. And then 1, 1. Yeah, that should work. That will reduce the size of instructions. Yeah, but not every instruction can have just one operand. I mean, it can if I were to use a second operand instruction, but I don't like doing that. So I guess I'll just keep it like this. Oh, whoops. Define. I should probably do all the ALU functions. So let's start with arithmetic. Add 1, 0, 0. Define subtract 1, 0, 0, 1. Oh, whoops. Multiply 1, 1, 0. And then divide 1, 1, 1. You know, I might have a different way of doing this that might be a little bit better. But I'd have to design the circuitry myself to really get it. Hmm. You know, I might not need LDP, but I'm gonna keep it because I like having P be separate. So instead, load a value into register. Wait a minute. That's right. I need to differentiate between you know, opcodes and operands for I need to differentiate between operands and my opcodes. There we go. I think that's all I need right now for arithmetic. So let's go ahead and go to logic now. So or let's just add a space there. There we go. Yeah, there's XOR. I don't remember copying that, but okay. And not there was others, wasn't there? What am I what am I missing? I know there was more. There's more logic. What is it? Or XOR and not. Oh, you know what? I'm missing a flags register. I might need to change that. That's probably too big anyway. God, what is the other? I'm gonna look it up. What are the... I actually need to click on it. There we go. What are the typical logic operations done on a CPU? A CPU's ALU. NAND? I don't think there's NAND, NOR, or XNOR. There's shifting though. There's bit shifting. Does that really go through the ALU? Okay. I can do that. So let's start with shift left. And then shift right. There we go. Oh. Okay. I guess the thing to do for ALU operations is to only have registers do them. Registers only. No immediate values. There we go. And that should make things a little bit easier for me. And then I'm going to need branching. Okay, so branch if equal, and define branch if not equal. There we go. Let's see. I guess branch if equal and branch if not equal are fine for now. And I'll add more later if I need them. That's probably the best way to go here. Yeah, I think LDI is going to be one of the main things with loading immediate values. Oh, branches 0 and not 0. Thank you. That's a good idea. Okay, branch if 0. And then branch if not 0. There we go. That's probably good. What was my thought process before? Oh, right. I should probably also have a NOP. Define NOP. And that's just going to be 0. Okay, I think that's everything I need for now. Oh! I need loading and storing with P registers. Wait, hold on. Memory pointer operations. Okay. Load store. I always get load and store mixed up, so that's going to be fun programming it in the future. Load from the pointer at P into at a P register into a general purpose register. Store the value at in a general purpose register to the pointer at a P register. No, I think it should be P register, general purpose register. There we go. Okay. There we go. Yeah. So, yeah, something I've learned is that immediate values, or more than one way of inputting something into something else, is completely and totally evil, and that is why x86 is complex instruction set and not reduced instruction set. Because that's really hard to do. You need a lot of instructions to do that. Like MOV itself has like 5 different opcodes for one instruction. Crazy. But yeah, I think that's it. These load and store operations are probably going to be especially important because obviously I'm going to have a frame buffer in memory that I'm going to write to. Should I have interrupts? I don't know if that's a good idea. Pointer register offset. Yeah, I could do that, but it's worth noting now that I'm probably going to be doing 100% of the programming in assembly instead of C, so it's better to put it like this because that's how assembly is done. Unless you mean something else and I'm completely misunderstanding. Alright. And so from here, I guess I should start implementing them, because that's really all there is, obviously. Okay, when this is done, I'm just going to put a return here to stop it from going through all the rest of the if statements. If instruction equals... I already forgot my list of instructions. LDI. Oh wait, that's already what it is. Duh. CPY, or copy. Registers. Yeah, okay, so it's... I'm trying to think of how I should do my syntax. Registers operand 1, no, operand 2 equals registers operand 1. Wait a minute. I probably don't need these. I'm gonna do it anyway. IR equals instruction DR1 equals operand 1 DR2 equals operand 2. The compiler will probably optimize that anyway. Oh well. It's probably important to do that anyway. So if the instruction register equals that, and then DR1, DR1, DR2, DR1, IR. There we go. And then if DR1 is less than or equal to R16 and DR1, or DR2 rather, is less than or equal to R16, there we go. And then return. And I'm also going to need the NOP in here. If IR equals not 0 dir2 0. Oh, I'm probably going to need a clear flags instruction, aren't I? Let's fix that right now. Oh wait, hold on. There we go. Oh, I'm going to need a return up there. There we go. And then after CPY, there's LDP. If, oh! There needs to be a get P, doesn't there? No! Oh, I can't believe I forgot about that. Ugh, it's gonna have to be this plus 1. Man, I can't believe I did that. I can't believe I forgot about that. Well, it's alright. It's not horrible. Just a reminder so I don't forget that. That would be really bad. Okay, so if DR1 yes, no, yes, okay. If PTR, oh wait, no, P1 or DR1 equals, oh, that's DR2, equals P2, and DR2 is less than or equal to register 16. Okay, oh, wait a minute. That could have been bad. There we go. Okay, so let's go ahead and try an instruction here. So, process instruction, LDI, R1, let's just do 256. And then print FR1 %D there we go. Now let's test it out. I, I, I thought you could do that. Is there a %L for longs? No. How to print a long with printf in C. Ah, %li. Yes, it is. %li. There we go. Isn't this the same thing? Is there an LLI? There is, okay. It works! Let's go! Oh, I wonder if I could just do, what's, X? Yeah. Aw, darn. I can't do that. Wait a minute. It's there. I guess I'm blind. I just didn't see it. Whatever. It's fine. I can do base 10. It's not that big of a deal. Okay. And I'm going to change this just a little tiny bit. There we go. Cool. Alright, everything in that instruction is working just fine. So next, R2, R1. And then I just need to print register 2 as well to make sure it's working. Yeah, I'm going to need to swap that around. Oops. Yes. Yeah, because destination, source. Okay. Cool. That works. My next processor is 16-bit RISC, but with base 4 numbering just cuz. Base 4? Why is that? Oh, well, just cuz, I assume. I mean, hey, if it works. Get C. I'm sorry, I don't know what that means. 3210. You've lost me, man. I don't know what you're talking about. Right. Next instruction. Right now we have LDP. So, nope, that's not what I'm looking for. LDP P1 R1, and then I'm just going to change this to R2, and let's do AA, and then make this just like that. P2, R2. Yeah, there we go. And then I take this, paste it there. DNA theme. If you're trying to make a reference, I'm sorry, it's lost on me. Alright, there we go. E1, E2. Okay. Perfect! Awesome. So far, all the instructions I've implemented work. Let me go ahead and just make a debug function. Okay, and then just to make sure that works, I'm going to do that. Cool. Oh! I probably need that. There we go. And then that should probably just be print debug. Another for loop. I guess the first 10 bytes of memory should be fine. And I'm probably going to separate memory into, what's it called? Into, quad words, that's what it's called. 4 bytes each, or 8 bytes each, rather. Nah. There we go. And then that should be working. Yes. Okay. So for loading and storing, I can't just do bytes at a time, right? No. Would I have to do 64 bits at a time? I guess I do. Unless I add a whole bunch more instructions, but that's... Well, I mean, that's ridiculous. 1 second. I guess I should base it based on the size of the register, maybe? So maybe I could have a couple of smaller registers, but I don't want to do that. I guess just being smart about where your pointer is the best thing to do. So let's first of all implement we have LDP, right? Yep, let's get get P. Yes, because we take from a P register and go into a general purpose register. Oh wait, hold on. That would reverse it, wouldn't it? Reverse my instruction scheme, that is. So I guess I should flip that around. Equals PTR1 else registers DR2 equals pointer 2. There we go. And then else error, and then return. So then, let us get P for P1 and put it into R6. Wait, I reversed that, obviously. Because destination, source, yes. It's still 0. I did something wrong. Ah, right there. Yeah. Yes, right there. Okay. Still 0. Okay, if DR2 equals P1 registers 1 equals Yes. I should probably put that inside of the if statement. There we go. Wait, I have that backwards again. Okay. Okay, that should work. That should be working, but nothing is in register 6. What is going on? I guess I'll just set a breakpoint here and debug it. Okay. It skipped over everything. Why? Hold on. Let me run that again and actually look at what's going on here. Operand 1 equals 5, which is register 6. And operand 2 equals 16, which is pointer 1. Okay. Huh? What's going on here? Everything should be working just fine, shouldn't it? Yep. Can I not set a breakpoint right there? Why not? Huh. I don't know what's wrong. Well, to emphasize, there isn't anything wrong. This is working. I don't know what to do. Continue. Oh, it just ignores all those breakpoints for some reason. Wait a minute. Is it because of this? Hold on. Let's just do 100 kilobytes for now. Nope, it's not that. Generally, that is because the source is newer than the bin. Really? Okay. I mean... Okay. There we go. That's... oh. Duh. R6 is still 0. Yeah, what the heck? I don't know. Maybe it's just with the register 6? Nope. This should be 255. What the heck is going on? If data register 2 equals pointer 1, or data register 2 equals pointer 2, and data register 1 is less than or equal to register 16. Okay? If data register 2 equals pointer 1, then it goes into the register that's in DR1, right here. Otherwise, it goes into the one... Otherwise, the one that goes into this one right here is pointer 2. Right? Like, I mean, I'm looking at this. I'm looking this over, and I don't see any problems. Line 60? Oh! I see it. Thank you. Thank you. I could not figure out what was wrong. Yes, thank you. I can't believe I didn't notice that. There we go. That was an easy fix. Programmer blindness, it's real, I'm telling you. Okay. So then, I guess we go through all of these now. The ALU operations, might as well blast right through them. If instruction register equals add if DR1 is less than or equal to R16 and DR2 is less than or equal to R16. There we go. I'm going to have to do a lot of error handling later. It's fine, I can go back through this. And if it's not that interesting, I can always just do it off camera. That's going to be very common. I'm just gonna stay with error. It is technically invalid register, but you know, whatever. Oh, I need to put these returns up here. Add sub mul. I'm just gonna copy and paste this whole thing, might as well. Times I'm going to need to set my flags, aren't I? Let's just do, what are all of our things here? Equal, not equal, equal, and 0. Okay. So there's 2 for that. And then I want to add carry, so that's 3. Okay. Yep. Equal 0. Equal 0. I already forgot what it was. Negative, or rather, sign. Let's see. Equal 0 sign. Overflow carry. Although I guess overflow can be carry as well. There we go. So that's 4, right? 1, 2, 3, 4, yes. I doubt there's going to be any overflows considering, you know, the whole 64-bitness, but you never know. Unassigned 64-bit integer limit. That's a big number. Let's put that in here. Hashtag define long max. Boom. Or rather, u long max. I'm sure that won't result in any problems. Yep. Okay. And then basically the same thing. Minus registers dr2 is less than 0. Flags 2, was it? 0, 1, 2, yes. No. Yes. Yes. Because flags 2 is sign. And then this right here, that's just a good old times. And then division. I guess that doesn't really happen. Oh, you know what? I need to get the, I forgot what it's called, remainder into a different register. Oh no. Remainder will always be in register 16. Oops. How to get a remainder in C? Ah, the percent. Something like that. Oh, I need a semicolon. Okay, I'm going to try out div right now. Div R2, R1. Nothing in R16. R2 is 0 now. I don't know how to do that actually. I don't do it very often. Okay. This is correct. Maybe there's just no remainder. I didn't even think about that. $18. And then, that's just going to be regular decimal. And then 7. Zero. 18. That works. Why isn't it going to R16? Oh. Probably because it should happen first. There we go. Alright. I'm pretty sure all the other ones work. Hopefully. And, I believe that's all of them. Yes. Oops. Alright. Registers, data register 1 equals registers, data register 1 or registers, data register 2. There we go. If instruction register equals XOR oops, just like that. And then XOR, I believe, is that IR, oops, equals, what comes after X or and. And then we perform that bitwise and. Not. There we go. Hello, Ramder. How's it going? And after not, we have shift left and right. This has just one operand as well. Shift left 1. And then the next one is basically just a carbon copy, except for a couple of things. There we go. Oh no. Did I miss anything? I don't think so. Ugh. Let's see. After shift right, we have branching. So, if IR equals jump, okay, this has one operand as well. Oh, I need a program counter. I'm glad I thought of that. This should probably only take immediate values. Oh, a stack pointer. Yes, that's a good one too. That is probably a good idea. Oh, and I need push and pop as well. Let me do that. Or top and bottom stack pointer like x86. Yeah, but the stack doesn't have to be super great. It just has to exist, I guess. I don't like using the stack very much. So let's add those instructions. GEP right there. Now I can probably get rid of that. There we go. That should be fine. I guess I don't need that check. Oh, wait, hold on. I'm going to need to change that instruction up a little bit, aren't I? Although I guess branching doesn't need to be done directly from a register. I guess people aren't really going to do that, like put a address into a register and say, hey, jump to that register. I mean, I'm sure there's a use for it, but, you know, that doesn't need to happen. so it's just going to be immediate. So the program counter equals dr1. Boom. And that's it, I think. There should be nothing else to it. Wait, no, there's just one JMP, isn't there? Branch if equal. Equal 0. I need a compare instruction. Let's do that. There we go. And then coding your own go-to. What fun. Yup, you betcha. Personally, I have never compares just fancy subtraction. Yeah, I did know that, but you know, if there's an explicit instruction for it, then you know, it's a little bit easier. Oh, that needs to be capitalized. PC equals dr1 and then if IR equals branch if not equal, it's basically just the opposite of last one. Flags 0 equals false. I should probably be using my true and false. C equals R1. Wait, I could probably just use a go-to, couldn't I? Yes! I could just have a specific go-to instruction that uses a pointer. That might not be a bad idea. If IR equals branch of 0 and not 0. Yeah, I'm pretty sure it's flags 1, right? Yes, it's flags 1. PC equals dr1. Return if IR equals branch if not 0, if flags 1 equals false, PC equals dr1, and then return. Okay, good. That's all now, although I should probably have a go-to. Yeah, okay. Man, there's going to be a bunch of just random instructions added to the end here. I might have to completely restructure the instruction set, but thankfully I'm using, you know, these definitions, so I won't have to actually change anything in here. Okay. If instruction register equals load. Pointer register, general purpose register, yes. I should probably declare memory outside of this. Just declare it though. Let's bring it up here, all the way to the top. There we go. And then all the way back down. Which one is load again, just to make sure. Load from pointer into a general purpose register. Okay. Registers er2 equals oh wait, hold on. If dr1 equals p1, else, there we go. Equals memory p1, then otherwise, oh wait, I can just do that, equals memory p2. There we go. And then if ir equals store, yeah. So I should just take this and then swap these around. Here we go. Why malloc versus just a large global? Well, because for some reason... Oh, I should probably free it. Malloc because, for some reason, if I just use a large global, I can't use quite as much. Like, if I were to declare a gigabyte-sized array, the program doesn't really like that. But if I were to malloc it after the program starts, then the operating system and the program take it much better. Okay, I think I'm going to try load real quick. Load P1 R1 store P1, R5. Okay, so in R5, oh, I forgot what P1 gets set to though. 255. Yeah, let's fix that. R1, let's just do 5. Wait a minute. Oh crap, it's separated into bytes. Oh, wait, hold on. That should hopefully do it. Why? It must be a modifiable value. What? Oh, wait. That's an issue. I should probably fix that. What's going on here? There. What? Did I mess something up somewhere? Or is it just because of these? It might just be because of the casts. Huh? What's up with that? I don't see any more. Okay. Okay. Does this just not need one? I'm just stupid. There we go. How many parentheses do I have to add to make this work? Just like that. Cool. That should work. Okay, so R1 gets 5. So at address 5, there should be 5. Or rather, address 5 with an offset. Yes. Because it's a little endian. What's up with that? Did I miss something here? Expected a declaration. What? It compiled fine. Yeah. Let's double the size of this loop. Okay, there should be a 5 somewhere. No, wait. Let's do 40. Where is that 5? Oh, wait. That might help. Huh, it's not in there. Okay, what is it? Load register 1 with 5, and then load pointer 1 with register 1. Okay, I guess that's not gonna work. Oh well. I can probably figure this out with some bit shifting here. To shift right. How many bytes in 64 bits? 2 for 16, 4 for 32, 8. 8 bytes. Oh wait, so 64 minus 8 is 56. So I shift right 56. Right? Where is memory allocated? I believe in the ELF file system, memory is allocated at the end of the file. I can't be too sure about that though. It's been a while since I've seen how C does it, but I'm pretty sure. Oh, my memory variable? It's declared up here, but it's allocated in the main function right here. Right, I was up here. P1 plus 1. Yes. And then I just take 8 away from that. 48. Oh, wait. Registers DR2. Shift right, 40. Memory P1 plus 3 equals, I'm gonna have to do this 16 times. I can put this into a for loop. Come on. That should do it. And then just swap all those P1s for P2s. There we go. That ought to do it. Let's see. No. Maybe I will just declare it as a big constant, or whatever it's called. Yes, a large global. Let me do that. Memory 1000 million billion. There we go. That's 1 gigabyte. Oh. I don't need free anymore. I don't see any 5s. Alright, I'm going to use the bathroom real quick. I really have to use the bathroom. I'll be right back. Let me just pull up. Okay, I'm back. Unit 64 and memory P1. Oh, maybe that's a good idea. Yeah, first of all, let's, there we go. Okay. Let me copy that real quick. I appreciate the help, by the way. Let me just go ahead and take your code. I hope you don't mind. P1 equals registers DR2. There we go. Hopefully that works. That just needs to be P2. Okay. Nothing. Huh. I could just have every memory address be 64 bits wide, but like, I feel like that's kind of a waste. But I guess it's gonna be doing that anyway. That would make everything easier. 64,000 million billion divided by 8. Oh wait, no, not 64 billion. 1 billion divided by 8. 1,000 million. 125 million. Oh wait, that can just be %D. Okay. And then we went 64 for 125 million. 125,000 million. Oops. 1,000 million. Okay. And then I can take these out. Okay, let's see if that works. Should just be at 5. Yeah, I'm starting to feel like something's wrong with the instructions themselves. Like load and store. 'Cause, like, yeah, this is all working correctly. Why is R1 0? It's load. Or store. It's because I have them backwards. That would probably do it. Let's see what happens now. Never mind. Hold on. Load. Yeah, okay. Load should happen after store. It's in R5, and from R5 to R1. What is in R5? 0. That should be R1 then. Okay. Wait, that doesn't do anything. This needs to be R5. Not R15, R5. And then address 5 is still 0. What's register 5? It's 5. Oh! Aha! It works. Okay. Cool. But I guess this does its offset in bytes. I keep forgetting how many bytes are in. I think it's 8. Yeah, it's 8. Yeah, there we go. Except it's at address 2 and not 5. I don't know. I guess that's fine. I can print it out in bytes. But, yeah, I guess a char is going to be 64 bits in this architecture. And, you know, it's not that big of a deal because, you know, it's the only data size that we're going to be working with. It makes things easier for basically everyone. It still has 1 gigabyte of RAM, although with only 64 bits, that's probably going to be used up pretty fast. I'm probably going to have to find a way to store a little bit more than that. But, 250 million might be good. Let's see. It looks like everything's still working. Oh, except for that. Oh, because it's not in the right spot. Let's just do 30. Although it's probably going to be at 16. Yeah, it's at 16. Cool. Alright. It's working. Cool. So now that we have all that figured out, that was kind of a mess. Let's go ahead and continue. So we have CLF. If IR equals CLF, flags. Oh wait, I should probably just do this in a for loop. Or int I equals 0. I is less than how many do we have? 4. I plus plus. Flags I equals false. Boom. There we go. That's pretty easy. No operands or anything. If push. I should probably have stack pointer be one of the pointer registers as well, or at least have, you know, an alias or a macro, whatever the heck it's called. Hex 12 for the stack pointer. Let's go up here. There we go. Else if dr1 equals p2, then else it's the stack pointer. What do I already have? Oh, it's that. Okay. Yeah, I'm going to need to change the name of that. There we go. I should probably remove all these breakpoints now. Gotta run. I'll leave it running for the view minutes. Thanks, man. I appreciate that. if IR equals push. Alright. Memory stack point. Oh wait, no. Oh wait, no, never mind. Equals registers only. Okay, if DR1 is less than or equal to register 16, else if DR1 equals I guess I could do I have an idea. So instead of it being a register, let's define a non-register value for being like the current memory value. So program counter, I guess it is. Yeah, let's define that as hex FF. There we go, program counter. If it equals program counter, then memory SPTR equals PC so this will probably be described as $sign or something in assembly. Wait a minute, I can just do that, can't I? Does that work? Let's see. Yes, it works. Cool. It just causes this to be white for some reason, but I guess that's fine. Oh, I need the return. And then if instruction register equals pop, and then once again basically the same thing. Ooh. Yeah, I'm also going to need to increase the stack pointer. Let's do that. There we go. And then SPTR minus minus. PC equals SPTR, or rather memory SPTR, and then SPTR minus minus. There we go. Okay, that should be simple enough. If you pop $, then it's simply return. Okay, cool. And then we have CMP. So then if IR equals CMP, once again, it's registers only. So if DR1 is less than or equal to R16 and DR2 is less than or equal to R16, flags. What are the flags? I believe it goes equal. I'm just gonna copy this so that I don't have to go a trillion miles up the page. Actually, I'm probably just gonna put that there. Okay. If register, so flags 0 equals true, else if actually that can probably just be an else. Else flags 0 equals false. And then if registers DR1 and registers, oops, I'm still inside of that, and registers DR2 equals 0, flags 1 equals true, and then else flags 1 equals false. I think that's all I need. Yes, that should be fine. At least for now. Now I can get rid of that. if IR equals go2, if dr1 equals p1, I'm sure recursion won't do anything that bad. JMP. I don't know why I suddenly am drawing a blank. Oh, right, P1. There we go. Else if dr1 equals P2, yeah, because JMP only takes 1, if I remember correctly. Yes. And then, so I just take this and do that. Else there was an error. Now I can return. Oh, I don't have return up there. I should probably add that. Return. Oh boy, how many of these did I miss? Okay. All right. Wait a minute. I can do more error stuff later. And that's everything, actually. So I guess now what I need to do is get a little bit of a graphics adapter going. And I'm also going to put this in a region. Actually, I could probably just put that in a header file. And I know which header file, too. Boom. There we go. Now we just make this static inline. There we go. And that should still leave everything working. Uh-oh. I didn't think about that. Okay, let's undo that then. It's fine. Pragma region, instruction processing. And then we go all the way down here and do pragma and region. Boom. And now I can close this and hopefully not look at it again for at least a while. So alright, let's do a little bit of graphic stuff just to make stuff a little bit easier and prove everything is working. So include, I believe I already have SDL. Yes. Okay. And then so pragma region graphics, pragma and region. Okay, good. Yeah, and since that goes by bytes, that should be fine. Although it really shouldn't. It's still at address 16, but it shouldn't be going byte by byte if it's doing that. Yeah, no, it should definitely be times 8. But then that puts it at address 2, and I don't think it's supposed to be going there. Because it should... Yeah, it should be going to address 5, because P1 is 5. I don't know. That's not a big deal. Okay, SDL. I actually don't quite remember how to do SDL. Let me open up my old one. Let's see, what am I looking at here? Right there. Display. Alright. I should have a whole bunch of SDL stuff in here. I guess I'll move that over here so that Visual Studio doesn't cover it. Let's see. SDL window. Window equals null. Render equals null. And then 640, 480. And it's going to be at 32-bit color depth because, you know, that's a char, 64 bits. Oh wait, 64-bit color depth? Oh! No, I think I'll... It might be a little bit difficult, but I can have the lower half of a register go in there. And then, yeah, use a lower half of a register and then an upper half of a register because I can use bit shifting. Yes, okay. I can do that. And then STL underscore window underscore shown. renderer equals SDL underscore create renderer window -1 SDL underscore renderer underscore accelerated. SDL underscore set render draw color renderer 0 0 0 0 RGBA. Yeah, that's 32-bit. Good. And then return. Wait a minute. Why does this need to be int? This doesn't need to be int. This needs to be void. There we go. No, not event 8. No, I'm not looking for that. Let's see. Texture, yeah, okay. Void update texture. Or rather, instead of update texture, it's draw pixel. No, I can't do that. UN64X, UN64Y. UN32. No. Color. Oh, that's gonna waste so much memory space, though. What's 640 times 480? It's like 64,000, right? 640 times 480. 307,200. Uh-oh. How big? How big is it? 250,000. Ooh! That's gonna be a huge amount of memory if I do it like that. At 64-bit color depth? I can half that to 153,600. Wow, that's a lot. I didn't think it would be that much. I don't know, maybe I should just make it be a graphics card? Or maybe I should reduce the resolution. Let's do that. 320, 240. There we go. 320 times 240. 76,800. That's a lot better. And then if I divide that by 2, 38,400. But one write will write 2 pixels. That's really bad. Unless I can have it be 32 bits. I can have like a store 32, something like that. Okay, let's add a new instruction. Define store double word. Boom. Okay, and then let's add it to this right here. If IR equals store double let's find the store. There it is. Okay. UN 32. UN 32 memory P1. I guess I have to multiply that by 2, don't I? P1 times 2 equals P1 32 registers DR2. Oh wait, no. Just that. There we go. Okay, let's see if that stores it in 8 now. Oh? Wait, what? But I've... Oh! Yes. That would probably be helpful. Okay. Still 5 at address 16. Probably because I multiplied it by 2 then. Which means that I don't have to do that. Let's see if that's the case. No, it... Okay, it's not at 16. It's at 8. Okay. That should work then. Although I don't like that. Should we get address 5, shouldn't it? So why is it off by that? 8, 16, 24, 32. Right. 8, 16, 24. Shouldn't it be at address 9 then? I mean, I guess that does make some sense. 8, 16, 24, 32, 40, 48, 56, 64, and that's 2 before 16. Okay, 8, 16, 24, 32. Huh. I don't know why it's doing it like that. Unless it's storing at 1 less. Let's store it at 0 and see what happens. Oh wait, hold on. Instead of that, I can probably just do that because P1 will be 0 anyway. And it's at address 8. What's P1 at? Okay. Yes, okay. Okay. That should probably work then. Well, actually, I can't say it should, actually. Address 8 is 5. Okay, when is register 5 at? It's at 0, okay. Wait, but it shouldn't be. R3, which I think has not been touched, so that will be 0. Yep, still at address 8. Okay, what would happen if I did store then? It's at address 16. Something's not right. I wonder if it's because of this. Yeah, this right here. Okay, let's see if that changes anything. I should probably go back here and do that. Still in address 16. Okay, let's instead do 0x 4, 8, 12, 16, 20, 24, 28, 32, and then exactly double that. There we go. That should help a bit. Okay, let's go ahead and do 9223 372 036 854 775 807. There we go. Long underscore max. There we go. Huh. I see. So then there's a problem with the load instruction then. Or rather, with the store. But what is it? I mean, I don't think I need that cast, but like, I don't know. I guess I'll ask ChatGPT. I'm trying to make a CPU emulator in C, and my memory is an array of unsigned long integers. Here is my load/store instruction code. But it seems to not be working right. What could the issue be? Maybe if I do this. And also, I should probably do this. Okay. Okay, printf. There was, oh, wait. Kind of error, or, there we go. \n, semicolon, just to make sure there was not an error. There was not. Well, that's definitely not supposed to be happening. That would explain that a little. Okay, so first of all, R3. Okay. Let's do this with both pointers. And then let's do R3, and let's just do 2. So it should show up at 18, but it stays at 16. What is up with that? Hi, I'm a fellow C coder. Hello. I too am a C coder. I like coding in C. I'm trying to figure out if something is either wrong with this right here, because I want it to print the 64-bit like arrays or indexes of the memory array, but I'm wondering if the problem is with the load and store instructions. So I'm not sure what exactly the issue is, but it should be at address 2. It should be right here, but instead it always shows up right here. Even if I say set this to 0, and I do it again, still at 16. And I don't know why, because it's not always set to 16. It's like it doesn't even consider them being there, you know? Yeah, okay. Yeah, and it doesn't say there was some kind of error, so something is going on. Memory plus pointer 2 and plus pointer 1? I don't know. Oh, I forgot to add the plus. There we go. Oh, I guess I do need that. Okay. There we go. What? Ah! The pointer to memory. Or rather, the address of memory. Does that get rid of it? No. Expression must be a modifiable value. How did I do this before? Can you stick the debugger on? Oh, yeah, I could probably do that. Let me just fix all that real quick. There we go. And then let's just set a breakpoint right there. Is so large that it is unsigned. Line 96, column 50. 96 is way up here. What are we talking about? Yep. How do I check for overflows? How to check for overflow in C. It does not overflow, I see. To create a control program, you must need to test for overflow before generating said overflow. Just put times 100. If that fixes it, you know what the issue is. I guess, yeah. First I need to figure this out. How did they do this? So if registers data register 1 is greater than 0 and A, or not A, but registers DR2 is greater than U long max, which, I mean, that's, I'm pretty sure that's correct. Integer constant so large that it is unsigned. Okay. I don't understand. Do I need to do that? No. Maybe I just need to decrease it by 1. Does that fix it? No. But that is the unsigned 64-bit integer limit. Also considering a linked list, if you're having pain with arrays. Yeah, I could, but, you know, I did learn how to make linked lists a couple semesters ago, but I forgot how to do that. I do have an example in one of my projects here, so if I really need to, I can look for it. But this wasn't a problem 5 minutes ago. I don't know what the big issue is now. Unsigned 64-bit integer limit. I'm just gonna straight up copy and paste. Cool, it's the exact same thing. Yeah, okay, it works fine here. It just doesn't work fine in the debugger for some reason. It's just a struct with a pointer to the next struct. Oh, yeah. I guess you're right there. That's true. Yeah, I guess when I did linked lists a couple semesters ago, I wasn't exactly, you know, I didn't know very much about C. Because this was back before December, and I really started learning this stuff back in December. Okay. So I guess I can just multiply it by 10,000 or 100 or whatever and see what happens. Yep, oh wait, hold on. That's because it was P1. Let's try one more time. Okay, it's not there. So, what does that mean? Oh! I named them wrong. That would do it. That would do it. Okay. Oops. There we go. And now... Yes! Okay. All right. It's working now. Whew, all right. Now that that is all out of the way, it should all be working just fine. But just to make sure, I'm going to use the D. Yes, it worked. And that is equivalent to the maximum signed or unsigned integer, which means that it's working. Good. Now I can draw individual pixels. I've subbed, but I have to go, but your channel looks cool. See you next time. Cheers. Thanks. You know, please come back anytime. I'm glad you could watch at least for a little bit of time. I'm just gonna keep working on this for probably an hour or two more, and then I'll be done for the day. So now that I'm here, I'm going to get the 32-bit integer limits. So hashtag define uint max 4,294,967,295. Define int max, that's like half of it. I don't remember what exactly it is, but you know. Sign 32-bit integer limit. 2,147,483,647. Cool. Okay. Now I can finally get back to this. I guess it does have to be uint 64 for the color. Okay. So it's just drop pixel. STL set render draw color. Renderer 0000. Uint 8 red equals 0. Uint 8 green equals 0. Uint 8 blue equals 0. Uint 8 alpha equals 0. Okay. If color is not equal to 0, red equals uint 32 color uint 8 actually color, because it's just the first 8 bits. Green equals uint 8 color shift right 8. Blue equals uint 8 color shift right 16. Alpha equals uint 8 color shift right 24. There we go. Oh, I spelled that wrong. There we go. Awesome. And then SDL rect underscore rect r dot x equals x, r dot y equals y, r dot w equals 1, and r dot h equals 1, so that we can just draw a pixel. And then SDL set render draw color renderer red, green, blue, alpha. And then SDL render fill rect renderer and R. Boom. Okay. And yep, that's exactly what it should be. Void update screen. And x equals 0 and y equals 0, because I mean, let's be real, we're not going to have a, you know, nonillion pixel screen. And then from there, for in I equals 0, I is less than, so we're going to have to go with the height. So 240, I is less than 240, I plus plus, for in I equals 0, or no, not I, j equals 0. J is less than 320, j plus plus. I guess in the future I'm probably going to have to make some sort of graphics card, but right now a frame buffer should be more than enough. Okay. So what's 320 times 240 is 76,800. So that number, I'm pretty sure, is 250,000 divided by 76,800 divided by 2. Because we actually have twice as many. Oh wait, no, minus, not divided by. Okay, that number. 1,000 million. No. Yeah, okay, 249,961,600. Really? Oh, yeah, that must be millions. Okay. So that's down here. Update texture. X, Y, RAM, 251. Oh wait, no, not 251. And not RAM either. I'm memory. Memory, that number. There we go. And then that needs to be a cast of UN32. And then we need to also do plus I. I plus 320 times j. There we go. I think that's how it's done. And then I don't need these x and y values. Instead, I need j and I. There we go. And then I'm going to need SDL underscore render present renderer. And then void close SDL. Actually, I think I'm just going to copy and paste it from my other program I've got here. Boom. Okay, awesome. And now I can go down and see what I'm looking for here. Okay, so I can do init SDL right here. And then close SDL down here. There we go. And now it's time for a function that actually executes programs, because this is starting to get kind of bad. So, void execute program uint64 program length okay PC equals 0. And while PC does not equal program length, execute instruction. What? Oh, process instruction. Memory PC plus, oh wait, memory PC plus 1, and then memory PC plus 2. Cool. And PC plus equals 3. Okay. And then right here, while SDL underscore pull event and E, which I haven't declared. I haven't declared an SDL event. I guess I can just do that in here. Or not in here, rather, but... Oops. That's not in the right spot. SDL underscore event E. Where do I declare the SDL event? It must be way up in my file here. I must be missing something somewhere. It's alright, it should be fine. Oh, there it is. While it does not equal 0, if e.type equals SDL underscore quit. Oh wait, this needs to be inside of this right here. And then return if we close out of it. Oh wait, that needs to be all uppercase. And then for keydowns, I'm going to wait for that. Now, screen. What's my screen functions here? Update screen. Update screen. There we go. And now, if I were to, yeah, okay, so I need to have a load program function. Uint64 ROM. There we go. And then uint64 length. uint64 I equals 0. I is less than length. I plus plus. Memory I equals ROM I. There we go. And load program ROM len. Oh wait, hold on. ROM len. There we go. ROM. Oh wait. uint64 ROM equals. Boom. Just like that. I think. And then uint64 ROM_len equals, how do I find the length of it here? It equals size of ROM divided by size of uint64. There we go. And then, let's see, LDI R1 FIF oh wait, 24, and then shift left minus 8 is 16. Oh wait, I can just do 4, 5, 6, 7, 8. Yeah. Oh, whoops. And then LDP P1 this address oh wait, I can't do that, can I? LDI R2 that, and then make that R2. And then in LDP, just gotta make sure. Right there. LDP. Yes, okay, I did that right. Okay. LDP P1 R2. Oh, I need a comma there. Store P1 R1. Oh wait, stod. There we go. Mm-hmm. And then JMP 0. What? What the heck? No, I don't mean that. Let's do -W. Undefined reference to update texture. Ah. Drop pixel. There we go. Fantastic. A segmentation fault. What led to that? In drop pixel. Passing argument 3 of drop pixel makes integer from pointer. You mean like that? But that's... Access elements in scalar initializer. What? Uh-huh. Okay, I assume that's the issue. No, it's not. I wonder if I have to do that. A double cast. Maybe that does it. No. What is up with this? Access elements in scalar initializer. What does that mean? Like, it runs perfectly fine. Okay, what would happen if I were to say get rid of the ROM? Oh, I haven't executed the program. That would do it. If it's not executing the program, then that doesn't really do much, does it? There we go. Another seg fault. What's causing it? What is causing that segmentation fault? I wish I knew. I wish I could just debug this, but it's just not letting me. Okay, maybe if I make it static then? Static. Does that help? No. How can I make an array of initialized elements in C? Okay, I did it right. Oh! Wait a minute. I need to declare its length. Ah, unless I do that, I assume. Let's see if that fixes it. No. What if I do that? I'm not doing that. There we go. Okay. So, what the hell is going on? I guess I do have to say how large it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There. Uh-huh. There. Makes integer from pointer without a cast. Oh, because that, I see. I see. So that needs to be 32. There we go. There. That should add the cast. That is a cast. Cast from pointer to integer of different size. What if I do that? No problems. Let's go. Oh, it's because I can't include SDL in this. Well, I can, it just... Visual Studio Code doesn't like it when I do that, for some reason. But I did fix all those problems that were problems, to be fair. Okay. So now that I have done that, I guess there we go. Now, hopefully, it should work. There we go. It's here. Finally, I managed to get here. Alright, so it's here. What if I did that instead? Yeah, okay. How can I get... How can I get an integer pointer out of a long pointer? An integer pointer out of a long pointer at a specific index based on the long size. There we go. Okay. Uint 32. Int ptr equals uint 32 memory plus this, which is definitely an abomination, but it works. Just gonna do a little bit of that. There we go. Times 2 plus I don't think I need a plus there then. And then star int ptr. Makes integer from pointer without a cast. It's a pointer to a uint32, so I mean, I don't know what you mean there. Still a segmentation fault? Here is what I'm trying to do. I'm trying to make a frame buffer of 32-bit color depth per pixel. This is the drawing function. But whenever draw pixel is called, it results in a segmentation fault. Why is that? I should probably get my memory here. Here is how memory is declared. And here is where the frame buffer starts. There we go. Wait, do I have it as? No. Wait. Maybe a little something like this. Boom. Oh. Ah, darn. Yeah, a segmentation fault. Wait a minute. It's here now. Oh, I don't malloc enough. I see. Times size of uint 64. There we go. And it's working! Oh. It was working. Okay. Divided by 2 plus y times 320 plus j. Oh, yes. I times 320 plus j. Okay. Oh wait, rather that should go there, and that should get gotten rid of. Oh wait, no, never mind. It shouldn't. So that should just be like that. Okay. And then if I debug it, darn! Wait, it should probably be I, then J. No, never mind. I had it right the first time around. Okay, I think I'm just gonna paste the whole program here. Here is my main file. Can you identify where the segmentation fault, not where, but rather why the segmentation fault is happening at drop pixel. There we go. I see. Well, I guess I can try it. Let's see if this here works. I don't see anything, but no segmentation fault? No segmentation fault! Let's go. I don't see any white pixel though. Progress. Yes, I'm still coding. Whew. I'm probably gonna end it for the day once I get my first pixel on the screen. That should be more than enough. Alright. So I guess maybe I get rid of that? What happens if I do that? Still nothing shows up. Did I add my increment and decrement instructions in my instruction processing? I don't think I did. I didn't. Huh. Do I have the increment and decrement instructions? I don't. I can't believe I forgot about them. Oh well. And then on instructions, GEP. GEP right there. DR2 equals P1. Okay. R2 P1. LDI R3 1. Add R2 R3. LDP P1 R2. There we go. What's going on there? No, like, exceptions or anything. That's weird. Uh-huh. How's that? Ah! 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. There we go. Um, 18. There we go. And nothing. Okay, let's see. And this worked too, correct? Yes. Okay. This is what I have now. And while there is no seg fault, nothing is showing up on the screen. How can I fix that? You know what? I think I am going to take this and just put it right here. Just set it to 10, 10, and uint underscore max. Just to make sure those functions are working right. That could certainly be the issue. Oh wait, maybe I should put this after that one. Boom. And then take this and put it down here. Okay, it is showing up. So at least that's not the issue. Okay. There must be something here that's wrong or something. But it doesn't look like it. Update screen function. Okay, what if I just take this? Just straight up copy and paste this right here. No. Okay. Instead, I'm going to take this. And then where is my debug? There it is. Printf. D \n. There we go. And now, it is in fact 0. Okay. What happens if I add this? Okay. clearly that is in fact outside of bounds. So it's not that. Why does that result in a segmentation fault when I close it? Well, that changes a lot. And it doesn't result in a segmentation fault when I close it then. Why is it different between the debug? Oh no. Oh no. Still 0 though. I wonder if it's because of this. There we go. That should bring it up to exactly 1 gigabyte. And then right here. There we are. Boom. And that number needs to be there and there. Does that change it? No. Yeah, and it's still 0. Oh, wait, hold on. I think I'm gonna stick with the 1 gigabyte though. I guess I'll have to ask ChatGPT again. Alright, new chat. I'm trying to create a CPU emulator in C. Everything seems to be working so far, but for some reason nothing shows up on the screen. Debug output shows that the data at the memory address at the start of the frame buffer is 0, despite me using load to set it to uint_max. What could the issue be? Here is my program. It might be the std function. Store dword. Right there. Yep, that would do it. plus memory plus PTR1. Okay. There we go. That should do it. There. And nothing. What if I do it here? 0. So what I want to do okay. That might be able to do it. Let's see. It just eventually runs into a segmentation fault, but not when in debug. Isn't that great? Isn't that just awesome? Okay. I can go ahead and remove those. Uh-huh. That certainly does not make sense. I don't know. Maybe I'll just try store. And that results in a segmentation fault too, but why? This doesn't. Typically indicates issues related to memory access or initialization that are sensitive to timing or state. Do I have Valgrind? I can install it. Might as well. Okay. Okay. Oh, there's that, which shows up. Couldn't really say why, though, because that really shouldn't be happening, but oh well. There we go. Conditional jump or move depends on uninitialized values. What? Okay, that's exactly what I wanted to see. Let's try that one more time then, see what happens. This is pretty useful, not gonna lie. I didn't do it right. There we go. Let's try that again, see what happens. I guess using malloc probably isn't the best course of action here. Alright, well, I guess I'll just... There. That should do it. Let's try this debugger instead. Ah! That's, yeah, I might want to get rid of that. Yeah, it just comes back out as 0. Still uses a malloc. Oh, because it's a mem check. Okay. I still don't know why this screen fills with red. Unless this is somehow overwriting my program code. I wonder if I need to put it down here instead. That might need to be done. What happens if I do that? It was working just fine before. So why isn't it working at all now? That's kind of weird. I want to get this done before I stop. Let's see. Well, let's just comment that out and see what happens. Aw, crap. Alright, you know what? I think I'll call it a day for here. I've been streaming for 4 hours. It's 8 p.m. I haven't had dinner. But, yeah, I guess I'll come back to this later. For those of you who joined, and the one of you that's still here, thank you very much. That's about it. See ya.